Hi everyone. In this video, I will be working through some of the questions and the readings for this week, and this will help you in solving the questions on the problem set and other questions moving forward by seeing how exactly to apply some of the general formulas which were introduced in the readings and the video lectures, how to apply those formulas to actually solve these particular questions. So the first question, which I will do, is from the reading on Monday, November 9th, so this Monday. And what I'm going to do is I'm going to be doing the question number 2 first. So here we're given the probability of R, the probability of S, and the probability of R or S. And we're asked what the probability of R and S. So these first 3 questions actually require us to use the general rule for calculating the probability of disjunctions. Okay, so if you see in question 1 and question 2, you're asked directly about the probability of a disjunction. So what you do is you apply the rule that was given in the readings for today, as well as a lecture for Monday, the day of this reading, which tells you how to calculate the probability of a disjunction, regardless of whether or not the disjuncts are mutually exclusive. But now the reason why I'm going to be doing 2 here is because in order to do 2, it involves a small mathematical trick. And so I want to work through this one because it's a little bit tricky. So let me switch to the other screen. So I'm just going to write down for myself though what these probabilities are. So the probability of R equals 1/2. Probability of S equals 1/4. And the probability of R or S equals 3/4. And we're asked, what is the probability of R and S? So now let me switch over. All right. So the first thing we do is we want to remember the general rule, which was given in the reading and lecture for Monday, for calculating the probability of a disjunction, regardless of whether or not we know that the disjuncts are mutually exclusive. And how that rule works is a probability of phi or psi, where phi and psi are any sentences whatsoever, is the probability of phi plus the probability of psi minus the probability of phi and psi. So in the case where phi and psi are mutually exclusive, this last probability will be 0, which means that that's why we know in the case where phi and psi are mutually exclusive, we simply just add up their probabilities. But in general, we can't assume that the disjuncts are mutually exclusive, so that's why we have to subtract the probability of their conjunction. But now, in this question, we're being asked what the probability of, we're not being asked the probability of a disjunction, we're being asked the probability of a conjunction, probability of R and S. That's what we're being asked about. But in the question, what we're given is the probability of R, the probability of S, and also the probability of R or S. So what we can do is we just flip things around in this formula to solve for this final term, right? So we basically take this formula and apply it where phi is R and psi is S. And then what we do is we add the probability of R and S to both sides, and then subtract the probability of R or S from both sides. And then what we get is as follows. That we get that the probability of R and S equals the probability of R plus the probability of S minus the probability of R or S. So this is a general formula for calculating a disjunction regardless of the status of the disjuncts. And what we've done is we've just flipped it around so that we can calculate the conjunction in this case, because in this case we notice that we're given, when we apply these variables, the sentences that are given to us in the question, we realize that we have this term, we have this term, and this term, so we just have to solve for this one. So we just flip it around. Okay. So now let me erase this. Now, so just to recall from the question, we're given that the probability of R equals 1/2, and that the probability of S equals 1/4, and we're also told that the probability of R or S equals 3/4. And so this is what's given to us by the question, and then here we've applied the general formula and switched it around in the right way. And so the rest is we simply just substitute in the values we know for the values on the right hand side. So we have that the probability of R and S equals 1/2 plus 1/4 minus 3/4. Now, of course, to do this fully, every step you would double both the numerator and the denominator of this to make it 2/4. But regardless, just looking at this, what you can see is that 1/2 plus 1/4 is 3/4. And then so 3/4 minus 3/4 is 0. And that is the answer to our question. It is 0.